Alright, so I think I'm recording. Let's take a look at these variation problems and see if I can help you here. Now, I'm going to have to make this just one large video because I'm running out of time this evening. So you'll be able to fast forward it and look at and hopefully find the problems that you need to check. Um, so here in the beginning, it's just a straightforward transformation into looking for keywords. When I see inversely, I think division. When I see jointly, I think that multiplication, but that more than one variable it follows. So here when it says x varies inversely, I have x equals my constant of proportionality. I usually use k. You can use c for constant. Those are the two most common letters that they use. Inversely, it's division. So this is telling me to divide by a, and that's what they want, the equation that represents that. Over here, f is jointly. When I see that jointly, I know that I'm going to have more than one variable that follows, and here I have m and a. And when I see jointly, I'm thinking multiplication, not division, so it's k times m times a. So those are my answers for my first two problems. For the next one, E is directly proportional to Q. So E is means E equals. And my constant of proportionality is always in my numerator. When I see directly, I think multiplication, so it's K times Q. When I see inversely, it's division, but it's not just R, it's the square of R. So R is being raised to the second power. Be careful and don't add an extra word. It doesn't say square root, but it's amazing. It's awful easy to accidentally think that it says that. But this is my answer for problem 3. Here for problem 4, I see that they're using both the words directly and inversely. So I have R varies. I know that my constant proportionality is always in my numerator. With directly, it says the square of t, which means t raised to the second power, and inversely with s. So I think division when I have inversely, and I don't have any exponent on s. So there's my answer for problem 4. In problem 5, it's taken it a step further. So let's take a closer look at these. The first sentence is just like it was in the previous problems. V is directly proportional. I have my constant proportionality. When I see that it varies directly or directly proportional, I think multiplication. So it's k times t. In this next sentence, it's given me enough information to solve for k, because as t and v change, k always remains constant. So when v is 49, the t is 5. So I have multiplication. To get k by itself, I need to divide both sides by 5. So k is equal to this 49 divided by 5. So what that means, if I return back to my equation, I now know what this k is. So I'm always going to have this v is equal to 49 over 5 times t. And they might give me different values of t and ask to calculate the corresponding value of v, or different values of v and find the corresponding value of t. It's like the x and y, and this is the slope. As x changes, y changes. But there's my final answer for this. Alright, so when I see, these are the directions. When I see q is jointly proportional, I'm thinking more than one variable follows. It's all multiplication. So I've got q, my constant proportionality, and since it says jointly proportional, it's k times m times t. Now, they give me enough information that I'll be able to determine what this constant k is. So it tells me that, let's see, on the left, that q is 12, that m is 0.15, and that t is 4. So I know that this k is whatever 12 divided by 0.15 times 4 is, so that's probably 2, but let's check and see. It's getting late, I'm getting tired, and I am not the strongest at arithmetic. When I key in my denominator, I need parentheses around it because I don't want to divide it by just 0.15. I want to divide it by that product. And, oh, see, I'm glad I did that because I think I said something else. Did I key it in right? Yeah. Boy. Totally. Was totally wrong, wasn't I? Well, that's why I use a calculator. That's why I'm not embarrassed to use a calculator. So my equation, this k, is going to remain constant. So I have 20 times m times t, and there's my equation, and that's my answer. All right, so let's look at this. People had some questions about this, mainly because of the scientific notation. The first sentence tells me that f is directly proportional, but I also see inversely in there, so I know I'm going to have a fraction directly proportional to Q1 and Q2 and inversely proportional to the square of R. Not the square root, but the square of R. So here's my equation. It wants me to substitute these values in. On the left, F is 1.08 times 10 raised to the negative 8th power. This Q1 is 6 times 10 to the negative 9th power. This Q2, 5 times 10 raised to the negative 9th power, all divided by r squared, and that's 5 squared, which is 25. So on the left, I'm not going to do anything with that right now, because this is enough information to figure out what k is. I can multiply these in any order, so I'm going to multiply 6 times 5, and 6 times 5 is 30. And since these have the same base, all I have to do is add the exponents. So negative 9 plus a negative 9 is a negative 18. 5 squared is 25. But I notice that I could have reduced that, so let's back up a second. I can write 5 squared as 5 times 5. And you see that I have a factor of 5 and a factor of 5 that divides to 1. So I just have 6 times 10 to the negative 18th in the numerator divided by 5. Alright. If I want to know what k is, I'm going to take this number, 1.08 times 10 to the negative 8th, and I'm going to multiply it by the reciprocal of this value. So the 5 goes here, because if I multiply both sides by 5, the 5's will cancel, and the numerator is times 10 to the negative 18th. Alright. So in the numerator, I have 1.08 times 5. So it's probably going to be like 5.4, but I don't know. I don't trust myself, especially after a minute ago. The 10 to the negative 8th, let's leave that here for a second, because I can see that if I write, because this is a negative exponent, I can move this up to the numerator and make it positive, and when I add these exponents together, what do I have here? 1.08 is going to get multiplied by 5, and this 10, I add these exponents together, 18 plus a negative 8, 10 to the 10th power, and all of this is divided by 6. So I'm going to jump to my calculator and see if it will tell me what this is. I've got 1.08 times 5 times 10 raised to the 10th power, and this is being divided by 6. So I've got 9 with a bunch of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I don't remember which buttons to push to get it in scientific notation, but your calculator might write that as the exponent is the number of zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I wish that it would put the commas in there for the the periods. So that's what I'm getting for K. Now I forget what the problem asked me. Yeah, it's not asking me for anything else. So it wants the equation. Let's go back and substitute in this value of K. Let's go ahead and use it as 9 times 10 to the 9th, so I don't have to write all those zeros. So I've got F is equal to, well, 9 times 10 to the 9th. That's my K times whatever our values for Q1 and Q2 are divided by R squared. So, if there was a part B to this problem, they might have given me different values of Q1, Q2, and R in order to calculate a different force for this problem. So anyway, that's my answer for problem number 7. Let's take a look at number 8. F varies directly with N. So now in the next sentence it gives me enough information to solve for K. So F is 75. N is 235. Let's divide both sides by 235 and reduce this fraction. So let's plug it in the calculator and let it reduce it. 75 divided by 235. It's going to give me a decimal number. But if I hit math and hit enter, it'll change it. Hit enter again. It'll change it to this fraction. So this guy, 75 over 235 reduces to 15 over 47, which means that my equation F is equal to, this constant remains constant as N and F change. So now that I know it, I can put it in there because it's always going to be that. So there's my equation. Alright, let's do the second day, because when people ask to do the variation, I'm not sure if they wanted day 1 or day 2. On the day 2, some of it might be a little bit harder just because you have to define your own variables. People go, man, where's the letters? And say, well, you have to come up with it. So a recipe for 2 dozen corn muffins. Let's read the problem. A recipe calls for 2 dozen corn muffins. A recipe for 2 dozen corn muffins calls for 3 cups of flour. The number of muffins varies directly with the amount of flour. So let's let N be the number of muffins. Or we could have used a capital M. I'm just going to let N be the number. And let's let A be the amount of the flour. Now, I remember that some people counted their muffins in units of a dozen. I'm just going to count my muffins in terms of just single units. So it's not dozens. It's just a single muffin. So 1 dozen muffins to me is 12 muffins. Alright, so in part A, it wants me to write a direct variation equation for the relationship between the number of cups of flour and the muffins. So the number of muffins M varies directly with the amount of flour used. So there's my equation that N is equal to K times A. It tells me up at the very top enough information to determine K. It tells me that a recipe for 2 dozen corn muffins, well, 2 dozen for me is 24 muffins. So 24, I'll figure out what this K is, and it calls for 3 cups of flour. So my amount of flour, I'm measuring this in cups. So if I divide both sides by 3, I'm getting that K is equal to 8 because 8 times 3. So in part A, let's update my equation, my answer to be that the number of muffins is equal to 8 times the amount of flour. So now in part B, I want to use this equation, use the equation to determine how many cups of flour, the amount of how many cups means the amount of flour. So I'm going to solve for A, are needed to make 6 dozen muffins. So a dozen muffins is 12, and 6 times 12 I think is 72. So I've got 72 is equal to 8 times the amount. If I divide both sides by 8, 72 divided by 8 is 9. So I believe that in part B it's asking, in part A the equation was N equals 8 times A. In part B I used that equation to determine the number of cups of flour that are needed to produce 72 muffins. So there's my answer for problem number 1. For problem number 2, we have, this you hear a lot being stuff because it's kind of fun. Sometimes if you have stopwatches and you have a lightning storm and stuff, you'll have students that, you'll have teachers that, or you'll assign, you got to be careful and stuff if you're outside during a thunderstorm, especially if there's lightning, but if you have a stopwatch and you watch for it, and let's see, when you see the lightning, you start the stopwatch, and then a few seconds later you'll hear the thunder, because light travels faster than sound, so you'll see it before you hear it. And the relationship, and who knows if somebody, this might be a very crude, a very rough relationship, but it says here your distance from a lightning bolt varies directly with the time it takes for you to hear the thunder. If you hear the thunder 10 seconds after seeing the lightning, you're about 2 miles from. So let's define D to be the distance that we are from our lightning strike when the lightning strike hits the ground, and that distance is measured in miles. And let's let the time be the number of seconds that it takes for us to hear the thunder. The time in seconds. So our equation, the distance varies directly, D varies directly with the time. So here's my initial equation. Now it tells me enough information that follows that to figure out this constant. It says that you're 2 miles away. It'll take 10 seconds. So if I divide by 10, 2 divided by 10 is 1/5. Or a decimal point, 0.2. But I like to use exact values. I like to use the fractions. So the distance is equal to 1/5 times t. So that's my equation. There's my answer for part A. And now I want to use that equation to answer a question. How many seconds will it take for the thunder to travel a distance of 4 miles? So on the left-hand side, when D is 4, let's figure out the length of time. Well, to get this t by itself, let's multiply both sides of this equation by 5, and 1/5 of 5 is just 1, and 4 times 5 is 20. So it'll take about 20 seconds for the sound to travel 4 miles. Alright, so let's move on to the next one. These type of problems you see a lot in chemistry. From the Boyle's law and Charles' law and all. I forget all that stuff. I used to know that stuff very well, but I forget that stuff over the years. It's been 30 years since I looked at that stuff. The volume of gas varies inversely as to the pressure. So inversely, I think division. So now it tells me enough information to determine K, the volume. And it gave me, this time it assigned the variables. I didn't have to come in and assign variables like D and T. It gave them to me. So let's figure out what K is. The volume is 200 and the pressure 32. So K, multiply both sides of the equation by 32 and we get 6,400 for K. So my equation is 6,400 divided by P. Now I have to make sure that they don't change the units on me. Here it's kilograms per square centimeter, here it's kilograms per square centimeter, so all the units and stuff are the same. What will the volume be? I want to calculate V. I know the constant remains constant. It's always 6,400, but this P, instead of being 32 kilograms per square centimeter, it's now 40 kilograms per square meter. So 640 divided by 4 is probably 160, but let's check it. And it wanted that V is in cubic centimeters. So if I take 640 and divide it by 4, 160. Alright, so there's our answer for part B. So our answer for part A was the equation, and our answer for part B was to use that equation to determine the volume when the pressure was given to be that amount of 40. Alright, let's take a look. Boy, I hope this is recording, especially the sound. Everything looks to be okay. That's blinking. I'm plugged in. But, there's really no way to know for sure if this is creating another silent movie, like back in the 1900s. Oh, hey, in class we get to watch silent movies. Sorry about that. Boy, I got to get out of here. Now I have to define my variables again. So let's let t be time. That's a big stretch. And that time is in hours. And let's let s be speed. And the speed of that plane is given in kilometers per hour. So it tells me what is the time varies inversely as the speed. So inversely, I think division. So there it's not giving me enough information yet to determine what K is. So this could be my equation. But then down here, it gives me enough information to determine what K is. So let's do that. 6 hours. I don't know what K is, but the speed is 900 kilometers per hour. So isn't that 5,400? Boy, I'm getting tired. So if I have alright. So my equation then is the time is 5,400 divided by the speed. That time will be in hours and the speed needs to be in kilometers per hour. So how long will it take if we're flying at a slower speed? Well, if it took 6 hours when you're traveling fast, if you're traveling slower at 800, it's going to take longer. So if I have 5,400 divided by the speed now is 800, so let's come into the calculator and 54 divided by 8, 6 something, right? 54 divided by 8, yeah, 6.75, 6 3/4 of an hour. 3/4 of an hour is 45 minutes. 6 hours, 45 minutes. So it's kind of what you would expect as far as when you're traveling faster, it was 6 hours. If you travel slower, it's going to take longer than 6 hours. 800 isn't all that much slower, so that's why it's tacked on to almost an hour. Alright, so let's see, is there... I'm going to have... I apologize that these last few, they're done in the same way, but I really have to take off. It's getting late. I can try to make another video this morning of these guys, so I'm going to stop right here and